Welcome to part 2 of the washer podcast. I have just 3 slides. I just didn't want to go too far over my time. So now we're revolving and around a vertical line, not the x-axis again, or excuse me, not the y-axis, and it's drawn in here. So now we go for when we integrate with respect to a vertical line. When our axis of revolution is a vertical line, it's going to be right minus left. Right? So I'm going to draw in what the other half of this would look like on our picture. So kind of like, oh, that, right? That's good enough. And, well, it's a little crooked, but there's our washer, our sample washer. So our outer function is going to be the curve x equals negative y squared plus 2. We already were solved for x, so that's good. We don't have to do that. So x equals negative y squared plus 2 is outside. And then the inside function is the x equals y. And that's inside. And this time when I write it, I'm going to go top to bottom so I don't cram my work. My work was kind of all over the place and I had to fix it on the last podcast. So first of all, volume equals. Let's find our limits of integration here. Remember, they have to be y values, right? So I think your graph is pretty clear here that we have y at negative 2, and then they intersect again here at 1. So that's our limits of integration, right? So limits of integration are x equals 1 and x equals negative 2. Again, since we're revolving around x equals negative 2, remember we have to show that increase in distance, we have to subtract it. So since it's to the left, it's going to be our function minus the axes. If it was to the right, it would be the axes minus our function. So this is to the left of the function. So it's going to be function minus axis. If it were to the right, it'd be the opposite. All right, so our volume is, the outside one is negative y, so we have negative y squared plus 2, so it'd be negative y squared plus 2 minus a negative 2, all squared. And then minus, and don't forget the pi. I have a tendency to write that in at the end, and the negative 2 and 1. The inside function, which is just the y. So again, we have to subtract the negative 2. Y minus a negative 2 squared. I feel like I have the wrong number of parentheses in here. Well, throw another one in here. Eventually, I think it works out. All right, so let's simplify and square. So our volume is pi evaluated from negative 2 to 1, negative y squared. That'll be plus 4, right? And I still have to square it. Minus y plus 2 squared. And oops, don't forget your dy. Cram that little dy in there. Let me see if I can move. Oops, I can move everybody but the integral sign. There we go. All right, let's squeeze in the dy because we're integrating with respect to y. There we go. All right, so now let's square. So we have our volume is pi evaluated from negative 2 to 1. This would be positive y squared. That'd be minus 8y, right? Negative 4y plus a negative 4y. And then plus 16. And then minus y squared plus 4y plus 4 right? And it's still dy, which I can't seem to squeeze in here because we haven't evaluated yet or integrated yet. All we've done is square and simplify and things like that. Ah, come on. Just move over. Everybody move over. A teensy bit, so I can squeeze a dy in there. Dy. All right, so now let's distribute the negative. We still haven't integrated. Negative 2 to 1. So we have y squared minus 8y plus 16 minus y squared. It would benefit us to combine some like terms here. Minus 4y and minus 4. That's everybody. dy. One more step before I integrate. Because I'm going to cancel out those y squareds, and then I'm going to combine. So I've got negative 12y, and I've got plus 12 dy. I don't think I made any errors. You can tell me tomorrow if you see anything I did wrong here, if I added something wrong. So now we'll integrate, and then I can finally get rid of the integration symbol. So it's going to be pi times negative 12y squared divided by 2 plus 12y, and that's from negative 2 to 1. So I do have to plug everybody in. I did take the y values, right, not the x values. Yes, I did. All right, so now let me simplify that. I'm just going to move over here. Volume equals pi times negative 6y squared plus 12y from negative 2 to 1. So our volume is pi times negative 6 times 1 squared plus 12 times 1 minus negative 6 times negative 2 squared plus 12 times negative 2. And then let's just simplify this. Volume is pi times, that's going to give me negative 6, positive 12. This is going to be, negative 2 is going to be positive, so that's going to be 4. Negative 6 times 4 is a negative 24. And then minus a negative 24 is a plus 24. And then we'll have a minus 24. We distribute that, we'll have another plus 24. So our answer here is going to be 4860 minus 6, so 54, right? So our volume is 54 pi. That's actually pretty big. All right, and there we are. All right, so if you see anything, let me know whenever you see it. All right, so I wanted you to see some different things and revolving around some different axes. I'm just going to sum it up and give you your closing, and that's it, and I should probably be done within another 4 or 5 minutes. So summary for finding volumes of revolution: draw a good picture. Decide if you're integrating with respect to x or y. It depends on which way your cross sections go, which depends upon which direction you're rotating. Right? It's a dx if you rotate around a horizontal line. It's a dy if you rotate around a vertical line. Figure out if you have a disk or a washer method, and I have some things on the next page to help you figure out disk or washer. Carefully determine the radius for a disk or the outer and inner radii for a washer. Right? So we have 2 radii for a washer, and we have 1 for a disk. All right, so here's a little example. The outer radius, so here we do have a this one is a washer method. I'm looking for my picture. So you see it's that green, that blue and red line, that's being rotated, and it gives us this funny looking bowl shape with a big flat bottom there. The green is the mirror image, that's what I was trying to say. So this is off a vertical line, and notice which way we're going. So we're going, our vertical line is to the right now. So now it's the axes minus the function. I go right to left, right? So in the other one, it was the other way, right? So this time it's axis minus function if the axis is to the right. Right? And we saw it's the other way if it's to the left. All right, so we're going to have our outer function there is the rightmost function. Or excuse me, is not the rightmost function. It's it's actually going to be the left, because when it comes around, it's the outside function. So sometimes you got to be careful. Make sure when we're thinking right, it's still going to be 4 minus, but we're going. If you notice, to the outside is the x equals y, not the other way around, because it's to the right of us. So our outside function, so we said we got to be careful. So once in a while, that the outside function, the upper function is not the outside, and once in a while, the right function is not the outer function. This is an example of that. And it's going to happen when we have our axes to the right or above. Right? So when your axis is to the right, it's going to be switched, right? So x equals y is the outside function. So we're going to have our outside is going to be it has to be within has to be with regards to the x here. So x equals y. Trying to see where I have it written down, and it doesn't seem to match my, because I forgot to subtract the y. I'm looking at 4 minus y, I'm looking at y. 4 minus y, sorry. Our outside, you have to remember to subtract the 4 from the y from the 4. 4 minus y squared, because that's the outside one, and then 4 minus the square root of y, because that's the inside function. I don't know why I have here 4 minus the square root of x. That should have been the square root of y. All right, so now we'd have to square those, and then we would just integrate and evaluate. So this would be a washer method because the figure does not border the axis of rotation. If you'd like, I'd be happy to solve out the rest of the way. It's just a matter of squaring and simplifying and then integrating like I did on the other pages. Okay. I have to say, sometimes when I have it written up here, I think, why did I write that? Oh yeah, that's what I wanted to say. We're integrating, by the way, with respect to y because we're rotating around a vertical line. We need to take cross sections perpendicular to the y-axis. So hopefully this kind of like sum things up. I think it's in your notes, and I'd be happy to solve the rest of this out if you want all the steps. And then my last thing is just how do you tell disk or washer? All right, so if your axis of revolution, first of all, you'll know it's the disk method if you border the axis. Washer method, you don't border the axis. The function doesn't border the axis. So if I put function borders the axis. Oops. Okay, we'll just move this up to give me some more space. Function borders the axis. Function doesn't border the axis. All right, so if our axis of revolution is the x-axis, our radius is going to be the function squared. We'll evaluate it based on what are our limits, where does the solid begin and end, and it'll be a dx. F of x is the length, d of x is the width of all of our little disc cross sections, or itsy bitsy teeny weeny little skinny cylinders. If we rotate around the y-axis or any if it's the y-axis, it'll be g of y squared. It'll be the function, but in terms of y. That will be using y values. C and D will be y values instead of x values. Maybe I should write that in. C and D are y values. And it's true for both of these here. And A and B are x values. It'll be similar if, let me write this down, are x values. If we rotate around a vertical line, not the x or y axes, but remember we'll be either subtracting it from our function or we'll be subtracting from it, one of the other. If it's to the left or below, we'll be subtracting it. If it's to the right or above, we'll be subtracting from it. For the washer method, we don't border the axis. For the x-axis, it'll be in terms of x. A and B again will be x values, and it'll be our top curve squared minus our bottom curve squared. And that'll be true for the x-axis, but remember, it might not be true if our axis changes and our axis is above. That'll switch. And then if we rotate around the y-axis, now our function will be in terms of y. C and D will be y values, and it'll be the right curve minus the left curve. And of course, dx and dy will always be the width of our little tiny discs, our skinny little discs. And it will change, remember ours could change a little bit if we rotate around a line that's not x or y. We're going to have to either subtract that in, either it's subtracted from the function or we subtract from it. That's all I have on the washer method. I hope that was clear. Please ask questions in class if it wasn't, or if you have any questions about anything. Here is your closing. Solve for the volume of revolution. I tried to keep this not too bad. And it's revolving around the x-axis. It's y equals 16 minus 2x. And so you have 3 lines here, and so it'll be your boundaries. So 16 minus 2x from x equals 0 to y equals 6. So that's going to define where your figure is. It will be a triangle, and it'll have a hole in it. So you're going to use the washer method, right? And it's about the x-axis. All right, so I'll see you in class. Bye.